Good evening. I hope you've had a chance to have supper, or if not, that you'll get a chance to get something to eat shortly after we break. But as you do, I'd like to pose a question. Do you know what you're going to put in your mouth? Honestly. Hi, my name is Bob Hanner, and I'm Associate Professor here in the Biodiversity Institute of Ontario. And over the next few minutes, I'm going to describe our world-leading research into molecular species recognition and how it's being applied to answer the question that I just posed to you. But first, we need to review some background on the diversity of life on Earth. Species exist because they evolved. Evolution is a process that has resulted in the bewildering diversity of life on our planet. And after more than 250 years of study using traditional approaches, scientists have described about 2 million species, based primarily on observable morphological differences of adult intact specimens. One of the grand challenges in biodiversity science is to enumerate the diversity of life on Earth. But with estimates of total diversity ranging from 10 to more than 100 million species, it's going to take a long time doing it the way we've always done. Fortunately, about a decade ago, my colleague Polly Baer here at the University of Guelph recognized that we can accelerate the pace of species identification and discovery through the comparative analysis of short fragments of DNA, a process known as DNA barcoding. This is a revolutionary advance because it's amenable to automation, and it's greatly facilitated by modern information systems and information technology. This makes it a scalable approach to inventorying life on Earth, one that is objective and repeatable and effectively democratizes access to this biodiversity information by making it accessible on the web. Since barcoding was first proposed, BIO has become the global headquarters for an international research program focused on building a digital, DNA-based identification system for all of life. Working with taxonomists from around the world, we've barcoded 5 million specimens representing some 500,000 species. And by genetically profiling these expert-identified reference specimens, we can use this barcode library to identify an unknown biomaterial based on its barcode, matching its sequence to the library. This is a powerful advance for many disciplines of research because species identification is not a trivial task, particularly when the morphological features used to tell species apart have been compromised. And this is the case for nearly all of the foods that we eat. Think of a fish fillet, for example. Hard to identify it to species once it's been made into fish and chips. One of my areas of involvement with barcoding has been the creation of barcode libraries for fishes. And as we began to accumulate data for many species from around the world, we wondered if our reference library was mature enough to identify the species that we regularly come into contact with in the marketplace as consumers. So together with students, we sampled items from food service establishments and retail outlets from Toronto and New York City. And we discovered that we could identify all of the products to species, but that 1 in 4 fillets that we tested was mislabeled. And that it was always a species of a lower economic value being substituted for one of a higher market value. A situation referred to as economically motivated adulteration of food, or more simply put, food fraud. Now this work spawned the curiosity of research colleagues around the world, and they replicated the studies elsewhere with similar results, showing that food fraud is systemic in the global seafood trade. And for example, more recently, we worked with the NGO Oceana, who collected more than 1,200 samples from 21 states for barcoding. And we revealed that mislabeling in the US in terms of seafood was rampant. Nearly half of all of the retail establishments sampled sold some form of mislabeled product. And we've also found that it's not simply an economic issue. Sometimes toxic species like pufferfish are making their way into our food chain under the guise of other species. Or things like escolar that are causing, if not serious illness, at least gastrointestinal distress for a period of 24 hours or so. Certainly not something you expect to get when you pay for your sushi at a nice restaurant. This indiscriminate application of names is also allowing for illegally harvested fishes to be laundered as something else, suggesting that food fraud has not only economic and human health implications, but also environmental impacts on sustainable management of our fisheries. Sadly, this problem is not limited to just seafood. Market surveys have shown that many commodities are mislabeled. Olive oil being adulterated with cheaper vegetable oils, herbal teas being adulterated with alfalfa. These aren't things that are found on the list of ingredients, they're adulterants. Natural health products are another commonly mislabeled and adulterated category of foods, particularly spices, ground meats. In their excellent new book, Sorting the Beef from the Bull, authors Evershed and Temple suggest that perhaps as many as 1 in 10 products on our grocery store shelves are mislabeled, and that the cost of food fraud to industry and consumers ranges from $10 to $50 billion annually. If you haven't read it and you're interested in food fraud, I strongly recommend the book. To help businesses, consumers, and regulators reduce vulnerability to food fraud, my colleague Steve Newmaster and I recently spun out a new startup company known as TrueID, which offers the world's first third-party DNA-based certification scheme to provide confidence that food is authentic. It's helping businesses to get a handle on their global supply chains and protect their brand reputations. We also believe that it will help protect Brand Canada and allow us to differentiate our products on global markets as the awareness of food fraud continues to rise and consumers demand that something be done about this. In summary, barcoding is a powerful tool for combating the adulteration and fraud in our food supply. Here at Guelph, we're also working with the Canadian Food Inspection Agency and other regulatory agencies around the world, but particularly here in Canada, to enhance Canada's capacity to use barcoding in a regulatory context, to identify not only food fraud, but also to more rapidly identify agricultural pests that impact our agricultural production systems, and to identify quarantine pests that can pose potential barriers to international trade. Very fortunate to work with some very talented individuals at the Biodiversity Institute. Our Director of International Programs is leading an outreach and training campaign in conjunction with the Convention on Biological Diversity to do hands-on training of scientists from the developing world and how to use these techniques. Our Director of Education and Outreach is leading educational programs for K through 12 students and continuing ed online courses in this area. Our graduate students are innovating new applications of this technology to support food security. We're training the next generation of researchers in the use of this exciting new technology. And within the coming decades, we'll also close in on answering that grand question of biodiversity science. How many species do we share our planet with? Thank you.